Welcome G. Let's start Kotlin tutorial. So today I am going to discuss about the basic data type that Kotlin support. Okay. In Kotlin, everything is an object. So this is the first point you have to notice. In Kotlin language, each and everything is an object. Okay, in the sense that we can call a member function or a property on any variables. Okay, so if yeah, everything in the object, then on this object you can invoke dot your member function or invoke its a property. Okay, so in every variables you can say. So if you say like you have a declare ball x equal to 5. So here this x is in a object. This is also an object. Each and everything. So this is the basic principle. Kotlin everything is an object. And on any variable, in any variable, you can invoke any function or method. If you're talking about a language Java, let's in language Java declare your primitive type like integer a equal to you write a 5. Okay, so these are the primitive data type. In this attribute you cannot invoke any function or you cannot perform any fields or function invocation, but it Kotlin each and everything in object. So object have a basic function, object can have a some function, member function and some property, so you can access those. Okay, so some types can have a special internal representation. So for example, you are talking about the number or characters Boolean can be represented as a primitive value at a runtime. Okay, so while runtime we have an option, we can generally Kotlin represent in a primitive data type, but as a offer to developer, each and everything considered as an object, so that you can invoke any member functions on that. So, but the user, they look like ordinary classes. And so, from developer perspective, from user perspective, whenever whatever we are using any variables in a Kotlin, each and everything should be object. Okay, but in the runtime, all the primitive values are presented as a runtime primitive value. So, as a while writing program, you consider each and everything in a object. And while when our Kotlin application is running at the run times, these are the represented primitive value. So, so what are the basic types? So generally, any programming language, there are some basic data type that language support. So in Kotlin, there are supports like number systems, or Boolean true false, or characters, or strings, and as well as array. So these are the basic data types Kotlin support. For number, lots of different kind of a number can be. A number can be your byte in short, longs. Similarly, Boolean have a possible value true or false. Similarly, character, you can represent any printable character in single quote. Strings, you can represent the sequence of a string in double quote. So these kind of data type as a Kotlin support, and consider each and every of things in the Kotlin is object. So object generally have some member functions in the property. So on each and every variables, you can access the functions and property. So let's discuss about the number. So as I discussed, the number can be two kind of number, maybe integral number or floating point number. Maybe you can consider one is the integral number, one is the floating point number. The integral number can have a multiple types, maybe byte, short, long, int. Floating point number can be double and float. Okay, so in the number system, first let's talk about the integer types. So Kotlin provides a set of built-in types that represents a number. So for an integer number, there are four types of different uh, uh, with a different size and the different value. So you can categorize integer in the four different types of integer as well as. So if you're talking these four data types like this way, so these integer types in Kotlin may be byte, maybe short, maybe int, maybe long. So how these are categorized? If you're talking about the byte, take only 8-bit, 16-bit, 32-bit integer, long 64-bit, and this is the all these types support your min value and max value. So if you're taking example as a byte, the byte is the min value minus 128 to plus 127. Similarly, 16 is the short minus 32 768 to 32 767. So in this way, similarly, if you're talking about the integer have a minimum value minus 2 k power 30 to 2 k power 31 minus 1. Similarly, long 2 k power minus 63 to 2 k power 63 minus 1. So these are the from minus to plus. So these numbers are categorized on the basis of value. If you type value 1, okay, the default, if you're not specifying any data types, they consider as integer. Okay, if you want, this is the not this you want to consider as long, then you have to specify L, this is the long data types, or if you want to specify byte, you can specify the byte. So if you tell ski I create a val x equal to 1. So this is the byte. This is the minimum syntax for clearing. This is your uh, the, any variable in Kotlin can be declared immutable or mutable. Kotlin support always you declare immutable val keyword. If you want to declare mutability, then you can use a var keyword. So the syntax, the proper syntax of a would be like you can say key ball x y colon data types int and your initialization return in this way. So the help of this value, your Kotlin compiler can automatically infer the data types. So we have an option. Here we have option. You can skip this. Here you are not specify your data types. So Kotlin compiler can automatically infer the data types of x variable as a int. This one number come as a int range by default. But you can say one also considered in a long, one also considered can a byte, one also considered a short. So how to specify? You want to specify this for default nature is all the integer number is considered int data types. So if you say x x and you can check println x is int or not. You can check what is the default nature of x. running, show that yes. So if you run again, this is the true. If you say, you can say here, but if here you can check y, y is int. Yes, you can specify the y is int. So if you are trying to say check by default, is it x is a byte. So here compiler say incompatible type. This is a byte and int incompatible. Here by default your compiler consider x is a int. You cannot check x is a byte. So this is the by default nature. If you want to specify the x is a byte, so while a specify byte equal to 1. So and println your a is a byte or not, they consider. So default nature of your integer is your integer, and if especially is specify if you want to make a long, so while b colon is you are specify 1, you want to check this is the uh, right. This is a print again. If say you have specified the L here, that is now B is long. So we have options in anyhow. You have to inform the Kotlin compiler that this I want to declare variable as a long. If you're not specifying anything, so on the basis of this value, this is considered as integer. Default nature of Kotlin is this is data type assigned as int. Or you can specify as manually int. Or you can specify this. No, this don't consider this is the by default here int. You consider I want this is a byte. You can specify data type is the byte. So in this way, you can declare integer data types. Okay, so you have options. The basis of your right side value of any expression, Kotlin compiler identify infer the data types. This is the in data types. This is the value. This value not come under this range, not come under this range. Okay, not come under this range. This under this range. So consider this is the long. Okay, and if you say this, you can manually specify I want this should be long here, or you can manually specify data type. This is the your byte data types. Similarly, number can be integer data type, number can be float data types. If you're talking about the float also have a kind of a two way float or double. Okay, so you have a if you float you will 32-bit size number and double is a 64-bit size, and so you have a this is the your significant bits. So all the floating number like here the is 3.14. The default nature in the floating point number is the double. So this is considered as a double. This is considered as a double. If you want to say I want to specify it should be float, so you have options. You can say F here. So by default, all the decimal number or floating point number is a float double. If you say here, well, C equal to 1.0, the default print your C is a float. No, compiler does not allow. By default, compiler support it's a double. So you cannot say this is the float. So default nature of your C is a double, it's a double. So default floating point number is the double. If you want to specify this is the float, so you can say well equal to 1.0. Then you can specify here f. Then say println e is a float. So you will consider each and every for this is true. Okay. So if when you want to any decimal number, the default nature is a double. Consider compiler, and if you want this should be float, so you have to specify a float here, or you can specify flat data types. If equal, you specify data types. I want to float, so here you can say float. But default nature of this is a considered as a float, so you have to specify f here. Okay, in this way you can say f is a float, it works. So in the case of floating point number, you have options. You default nature of floating point number is a double. You want to specify specific, you have to sf to make it a floating point number. And let's look like one. Let's key you have a write a function. No, the Kotlin support you can define function inside another function. This is the local function, and take one argument your double. Okay, and here you can just print. So what value you can pass? If you pass val I1, so it's not a double, so not allowed. You can pass D, yes, it's allowed. It's allowed. If you try to pass a float number, no, you cannot pass. So Kotlin are very statically typed language. So whatever you value passing, they are checked at a or you value you are passing correct data types or not. So let's say we have defined one print double. Here let's say we receive a DO double. Print your double number. So Kotlin offer if your function have only one line, then you can don't need a write a like you have option you can skip this and you can skip this directly instead of this you can equal to operator. So here I am written dictionary. So if you say here like print double, here you can pass like any number. So default number is considered is the integer number, so you cannot pass here. So you say let's I declare well any number a1 equal to 1. You are trying to pass a1, not allowed. By default is considered integer. Okay. If you pass, always try to use a ball keyword. If a ball well a2 and they say it is the 1 2.0. So by default all 40 number consider, so it's not allowed. If you try to say this is the v2, so it's allowed. Or you can say another number while v3 equal to, let's give this 3.0 is because floating point number. So you try to pass either v3, it's not allowed because this function only considered double. You can only pass, this is a by default double you can allow, the integer not allowed, your floating point not allowed. So this is the So in this way, you have to type mismatch not allowed by the Kotlin. You have to ensure whenever you are going to invoke a function that should be match proper your data types. So the what is the literal? Literals is the actual value which you are assigning to a variable like 123. This is the decimal number by default consider number. And if you want to make this should be the long, you can specify L as we discussed. This is the long. Similarly, we have a hexadecimal number as well as you have if you have any number binary, you can say this is the binary number as well as. So these are the literals are just any integer value, uh, actual value known as your literals, and that is the kind of constant value, and you can assign your variable as well as. So in Kotlin, you can support your decimal number, you can support hexadecimal number, you can support binary number, and but Kotlin does not support octa number. You know, octa number can start your 0 and then 1, 2, 4 till 8 number. So starting point 0 is octa number. If you say 0, 1, 0, 24, 0, 27, but this octa number is not supported in the Kotlin, else decimal, hexadecimal, and binary numbers are supported. Similarly, if you're talking about the Kotlin, also support your notation for floating point number. This is the default. Your I'd say the doubles by default. These are the double. These are the doubles and exponential. You can say exponential number as well as floats. If you want to make this should be float, you can specify minus f for small f, yeah, plus f. Then this number should be a float. For a readability purpose, Kotlin also support you can use underscores to make number constants more readable. Like this is the if you write a 1 million, you can say one underscore triple zero and triple zero. This way you can write 1 million. So this is allow you can say ball 1 million and then you can say one underscore underscore. It's allowed 1 million. So for the so that your number can quickly readable. So if you whenever you are printing this number would be actual the 1 million number. So only for the readability, Kotlin say you can write a long number with underscore so that easily you can read while reading the code. But whenever they are going to run, actually look like a normal your number system. So and these number systems you can maybe if you are writing a credit card number or in secure social security number or even you are writing some hexadecimal number or binary number, you can place your underscore so that you can easily read your numbers. So that is the very handy features of Kotlin, and this feature also support other language as well as. So sometime need to we have a study the different data types for number, maybe floating point number, maybe integer number, and we have sometime conversion needed from byte to short, yeah, short to byte, yeah, into byte, byte to long. So sometime some default conversion happen, and sometime you can explicitly need a conversion. So due to the different representation, so smaller types are not subtypes of bigger types. This is the thing. Okay, so those smaller types are not implicitly converted to the bigger types. So this is the your so this is the you can say rule is that you can if this meaning that assigning small data types to int. This requires your explicit conversion. Manually, you have to say. So smaller data types here, simply smaller data types are not subtypes of bigger data types. The bigger data types your long, okay, and then your by int, then your short. then your byte. The byte is the smallest data type. So is byte smaller data type is not the sub types of this we consider. So similarly, not a subtype, not subtype. So sometime if you want to convert byte is a smaller data types and you want to an int value, so this is right to manually express. See, let's here one you have a byte b and you want to specify in a integer. So you consider ki byte is a small data type, so then you can assign to int. No, these all are the values are in Kotlin is a not a primitive value. This is the object. So you cannot directly typecast. So if you are trying to say like we have a call uh, weave and this is specified byte and you say this is the one and you are say like uh, uh, you have a let's key a and you are trying to assign like b11 is work, okay, and you can say ki no ki this is the I want to int, specify your int, then it's not allowed. Okay, so if you are trying to convert your byte to int, it's not allowed. This byte is a smaller data types. You are trying to convert in a bigger data types, so this is not a kind of a subtype. So these all are the object. Okay, okay. So on your super data types variable, you can assign small data types. But in here, this is the number system. So whenever you want to specify by byte to int, you have to first convert your this byte value to the integer, and then you can convert. So I will do here in this way now not feasible. So what you do, we have options. This is the these are the object. So object have some method. So you can here method to int, and like in this way you can allow. So all the data types have provide is conversion method. So in which data types you want to convert? Just convert, invoke the particular method. P1, whatever your byte, and convert to it. So here say you have to your be the byte data types, then to int convert, and after that you can assign. So this is known as explicit conversion whenever you need. And the all the number types, all the number types some more support your conversion method. So if you byte class, if you want to convert 2 byte, 2 short, 2 int, 2 long, 2 float, 2 double, 2 char, whatever you want, you can convert. So this is the handy method as a Java offer. Here you can say dot. You have a two, and this is the two int, byte, char, double, float, long, short. These are the auto conversion method available. Whatever you want to convert, just use the specific method, and your value is convert, and you can assign to the respective data types. So this is you please know each and every data types you have this method. Okay, these are the methods available. So whenever you are going to assign from a type a type to b, so please use dot to dot to b type, and b type you can assign. So whatever value you are assigning from right to left, okay, and if both are the different data types, then we have to need a conversion. And for conversion, you can use this your handy method. And sometimes you should know some. This is the explicit conversion what we discuss. Implicit conversion is really noticeable because the types is infer from the context. So sometime compiler automatic infer your types and conversion. So those known as implicit conversion, you can say, just like your arithmetic operations are overloaded for appropriate conversion. So sometimes say कि here is the long number and you want to plus your by default integer number. So long plus int, this is the long. So this plus due to the plus operator overloaded, this is implicit conversion happen. You are not manually as a developer going to convert. So sometimes your Kotlin compiler automatically do conversion on behalf of developer. That is known as implicit conversion. You say call x, let's give a1 a1 equal to, you say let's give 10, this is a long number, plus you are plus 50, a1 is already defined. So let's a2. Okay, enter that. You say a2. So this way, here your this number is automatic after calculations they are converted. So you have to notice this is the auto conversion. So your long number plus int number is to converted to the long number. So Kotlin supports some standard set of arithmetic operation like you, all are the object, but all are the object you can. This is the object, your long object. This is your int object. This is a true object. You want to perform your plus operation. The plus is operations. So Java, in the Kotlin, these operators are overloaded so that you can use it. So these operators like a plus, minus, multiplication, division, and modulo, all are operators you can apply on your object. But in the case of Java, these are the primitive number. Primitive number you can manually directly apply. But here is the concept of your each and everything is the object. So this all conversion is implicit conversion. So here you can say 1 plus 2 or minus number or division number or subtraction number. So these these are the number generally required the primitive value to perform the two add number. But this is another object. This is another object. So here plus operator is overloaded to work on different arithmetic operations. So this is the you can say major mindset we have changed in Kotlin each and everything object. And here you can say you can say println say like the five is in them, and here you can say any here a2 a2 and sorry a2 you can check is long. So is the long types. Okay, this is your long types. What the value they have convert long types. So each and everything sometimes your Kotlin compiler automatically make a conversion for you. So please be ensured this is the known as implicit conversion. Sometime compiler is need your input what you want. That time you implicitly provide a conversion. And these are the also for your equality checks here, comparison checks here, range you can say check. These are the operator you can apply. This equal to, not equal to, less than, greater than, less than equal to, greater than equal to. And this is the range a to b. X you can try to say x inside a to b or x not inside a to b. This is the range from a to b. So these kind of conditions you can also used on your all the your number systems. Similarly, till now, all the data types, the integer data types, we learned about this support one minus number to your range is a plus number. Okay, this is the zero. This is your plus number. This is your minus number. So sometime I want don't any a negative number. I want only work on a positive number. So for that, Kotlin also supports some unsigned integer as well. So similarly, we have byte is the signed integer means from 0 minus 127 to 128 to 127. Similarly, short, similarly int, similarly long. So you have an option you can express unsigned, 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 unsigned. So unsigned number you cannot only support your positive number, your positive number, your positive number. 0 to 255, 0 to 65523. So here you say let's I say bell A3. Here you say this is the by default you can assign your minus number minus 5. It works. But you say key don't allow the minus number. You can say here unsigned int. So here you can now you cannot allow mismatch. So you cannot assign integer signed to unsigned int. So this is the you can say check. This is not allowed here. You only if you allow the positive number, it's allowed. So this is the conversion needed manually. Unsigned integer. If let's then dot to it. Oh, sorry. A3 A4 A4 key show println. This is the A4. 3 also works. This is not A3. In this way, you can say, or flatly you can write here. I think A4 you can write 5. So always literal unit. So whenever you have a by default this is the integer. So integer you have to convert to unsigned integer, then it works. So do we have a handy method to if you have any constant number you can declare and after that you can convert whatever you want. Similarly, we have to also support kind of some this is the disconjunction, yeah, conjunction, logical or logical and logical not you can use with the all same as like we know the definitions like here if you have a one variable boolean true and false then true false or and are not so you can apply if you apply the logical or that means any true it's considered true false any if first is a false then second not evaluated so these are the short circuit operators or evaluation this is not just change true to false or false to true and logical end say support both are the true then say true if any one true it's considered true yes if any false considered false you can say so in the white circuit this is the short circuit if you are talking r your first operator is the true the next is not evaluated here and logical r and say if first is the false next is not evaluated This is just inversion. So similarly, we have a number system. Similarly, we have your character system. Character is a single characters in single code. Whatever you are writing on as a character. So here, if you say while ch equal to single quote a, so this is a if you say ch is a pair. So anything you can define into single quote as a character data types. And similarly, we have a Boolean data types. Boolean is considered as a only two possible value, are true or false. Okay, and though show sometime it a Boolean as a nullable, and then you can say if you say this Boolean question mark, then it can also have a null value. But if a flat Boolean you are using, this is the only two possible value, true and false. So string is also considered as a data type, but this is the kind of a special class. So you can say a string is the string in the Kotlin also represented as the types, one of the data types like a string. The string is generally string value is a sequence of characters. Okay, the character is a single character, and we have seen a sequence of characters. You just in put in double quote. Double quote, that is the, if you double quote and put the list of your characters. Now this is your strings. So while s equal to double quote abc. So this is your string. String. A string. So in this way, you can write a string. So we have an option. We can declare strings. We can declare number system as well as. So so if you these are the sequence. Also sequence of character. If you want to, what is the sequence this, what is the sequence this, what is the sequence this. So you can say element of a string are characters you can access by indexing as well. So you can index your size of 0, 1, 2, 3, 4 as well. You can iterate like this way. So here you have options. You can want to like your for loop, your C, and you can use into your S string println, and it's just you're printing individual characters. So in this way, you can retrieve one by one characters, one by one characters. So we have options. You can retrieve one by one characters. Then we have it. So internally, this sequence is also array with a positional data: 0 position, 1 position, 2 position, 3 position. So this is the 0 position, 1 position, 2 position, 3 position. You can get a data. So this is the also string considered data types, and we in the strings are immutables. Okay, the once you initialize the strings, you cannot change its value or assign to the new value. And it all the operation that perform the string returns to the new strings. If you have some modifications operation they're performing, they always return a new string object. So you're leaving the original strings is the same unchanged. So immutable means once you created and all the things you are like here you have strings ABC. So you can say true uppercase. So new in the case of create a new string object, not the original string object you cannot change. Let's say here you have a options println println print s, and you try to say s dot to uppercase, or you say again you're trying to s. So this is original is not changed because you have to two uppercase this return new object. But old one the same. You can perform some string manipulation, but the string is immutable. This create a new object. This create a new object of strings. This is the unchanged. This is the unchanged. So here is the example. Is the ABCD uppercase and 2. This is the unchanged. This is the same. So to concat strings, use the plus operator. So here plus operator is also overloaded. You can append, you can concat to string as well as. And so if you are going to use the plus as a concat operation, your first left hand side operator should be string. Then you can append a plus one. Okay. Say here, if you try to say all ss equal to, let's give your abc, here I try to say plus 1 println ss, and so in this way your concat happen as a string append. We see one. So in this way you can say you can use the plus operator to concat the multiple strings. Conditions, the first element should be in a strings if you want to string manipulations. Similarly here s is your number, you can append your def. So what happens? S is the finally your string, then you can append, let's say here say plus EFC, and you can run it. Okay, it works. So these plus operators are overloaded for string concat as well as. So string is immutable. Whatever modifications or transformations you are performing, that result outcome is a new string object. Original object is unchanged. So please be, you have any kind of operations you perform on a string that returns always a new object. You're leaving the original object is unchanged. So this is the meaning of string immutable. So once you initialize, this object cannot change. You can reassign, you can do any operation, but original string is always unchanged. And sometimes this is a one concept known as strings, in Kotlin support string templates. What means string literals may contain your template expression. Template means you can place the dynamic value, okay, the piece of code that can evaluated and whose results are concatenated into the string itself. The template expression start with the dollar symbol. Okay, so here say I equal to, in between the your I, okay, you can space dollar symbol and the I variable. Here the value of I, what the value of I is evaluated, and the result would be the place here. Let's key I is equal to 5, and it's a parental. If say equal to I is equal to, you have to use the dollar symbol and then your value. So here the value of I is the evaluated and print. So this is the template. You are just specifying the whatever the value of I, just place here. So this is the concept of a string templates. The strings in Kotlin, in string we have a template. You can any value can inject at the runtimes. So similarly, if sometime this is the each and everything in the object, you have to perform some dot and some value. Let's give a dot length. Your dot length. So any you are going to use any property of the particular variable, then you have to use this open curly brace. This now this value is calculated. If you are not using this open curly brace, this is considered as only $s value are appended here. So if you say well ABC equal to ABC and ABCDEF, okay, and you say print and then you say you say ABC dot, you say let's, you are trying to say dollar abc dot length. Okay, here just you don't write this. This is length equal to, here you try to say a dollar abc dot length. So in this way you can write. So if when we have options, you have use the here, say here this is just abcd value. What is the actual value of abc are placed here, and this is dot length is considered as a string. And here you specify your open curly brace and dollar. That means this is the, you are going to access the property of this abc object. So please consider while string template, be ensure whenever you are going to access any property or any functions, then you have to use this open and close curly braces. Then it works. And this is the dollar symbol. This is the template. Now this, the value of this will be replaced about the what the value contain. So in this way, string template also we can use. So this is the complete, you can say, the basic data type what a Kotlin support till now. Basic data type support your number systems, your Boolean, your characters, and the sequence of characters you can say consider as a strings. Okay, and your number system can be your integer number or your floating point number. The integer number can have a different data types. We have a study byte, we have a study short, we have a study int, we have a study long. Similarly, float have a your float or a double. Do have a two floating number. Character have a single quote any character. Boolean have a possible true or false value, and sequence of single quote is anything your character, and double quote sequence of character considered as your strings. And in the string we have a support your string template is a dollar, and place any the template value can be placed here. So in the case of your number system, by default consider as a, if you're not specifying data types, they consider as a int. And in the floating point number, we are not specifying anything, this considered as your double. I know all these data types are object. Okay, all are the object, and this whatever the variable you are going to assign, this variable can, from this those variable you can access your number. Like it's like you want to some implicit conversion, that you can invoke two a list, two int, two float, two byte, two char. So these are the, you can say, explicit conversion methods are allowed. So these are the basic data types you can say in the Kotlin support, like for number system, for Boolean, for character, and for strings. Hope it's now it's clear what kind of a Kotlin data type support. First things in Kotlin, each and every thing in the object. Whatever value you are assigning in any variables, maybe var or var keyword or val. After in those variable, you can access your member function or a property. So here again, I would like to say thank you for watching this video.